All right, good morning, class. Before we get started on today's lesson, we are going to do a quick review. So the first day this week, we went over decomposing and composing figures to find surface area. And then the second day, we did volume of 3D figures. So I have some up here on the board. We have a cube. We were finding the volume, how much it could hold. And then yesterday we worked on drawing polygons on a coordinate plane. So we're just going to do a quick review of drawing our polygons. So to start off, we have our coordinate plane. What is this horizontal line called? What do we call that line? Right, we call it our x-axis. This is our x. Right here, all of our x terms go on the x line, right? And then what is our perpendicular line called? Y, or y-axis. Right. And then at the point in the very center where they cross, that's 0, 0. Now when I say 0, 0, I have two numbers, right? We have a 0, 0. So here's a set of points I have. What does the first number represent? Does that go on the x-axis or the y-axis? X. X always comes first. Like in the alphabet, that's a good way to remember it. X, Y, Z, right? So X goes first and then Y in our parentheses. So we're going to draw a polygon and you're going to have to tell me what the polygon we drew is. So our first point is -2, 1. So our first term is the X, so we're going to go to our x-axis, so we're going to go to -2. And then our Y is 1, so we're going to go up 1 and put a dot. Our next set of points is -2, -2. This one's an easy one because we have to go to -2 on both. So we're going to go down 2 for the x, down 2 for the y, and put a point right there. Our next one is 3, -2, and our x goes first. So we're going to go 1, 2, 3, and down 2. Always remember that this side of our x is negative and this side's positive, right? We're going up, we're going further that way, we're going positive, we're going back negative. And for our y, the higher we get, the bigger our numbers, the lower we get, the lower our numbers. So our negatives are on the bottom and our positives are on the top. So we have one last set of points, which is 3, 1. So we're going to go 3 places for our x because 3 was first. And we're going to go up 1. After our points are drawn, we're going to connect them. This isn't getting perfectly straight because I don't have a ruler. But what figure is this? What polygon? It's a rectangle. And so that's how we draw a rectangle in a coordinate plane. We use points and we find a rectangle. Okay, so today, now we're going to go back to our first day. We're going to work on surface area, but we're going to have a new way of finding our surface area. So what we're doing is we're turning our 3D figures and finding the surface area of 3D figures. And in order to do that, to help us best do that, is we have to put them into their nets. We have to make them into nets. And now that might not make much sense, but I have a video to explain it. But a net is pretty much when you take a 3D figure, like this cube, and you unfold it. So we're going to take this side down, we're just going to unfold it, and it's going to end up looking like this figure right here. So for volume, we were looking for the inside of this 3D figure of the cube, and now we're looking for how much the outside has, the surface area. So I entitled this lesson, Catching Area with Nets, because in order to find our area, we have to find our nets first. So first I have a video for you guys to watch, and it's going to show you a bunch of different figures. Don't worry, we're not going to have to go over all of them. Some of the shapes you might have never even seen before, but we'll start that right now. Okay, so I hope you have a better understanding of what we're doing, how we're taking a figure and we're unfolding it and putting it into a new form. It's the same thing, but now we're going to find the surface area of it. The reason we do this, finding the surface area of this, we can use this for a lot of different reasons in real life. For example, if we have a box and say it's someone's birthday and you filled the box with stuff and now you're going to wrap the box, you have to know how much wrapping paper you're going to need. And in order to find that, you're going to have to find the surface area of the box because you're not wrapping the inside, you're not filling the box up, you're only going around it, you're just doing the surface of it. So in order to make it easier on ourselves, we're unwrapping, we're taking apart the box, laying it flat out, and measuring our area, finding our surface area of the box, so we know how much paper we have. And I have our areas up here on the board, because we did this the first day. A equals S squared. That would be for our square. When we have a square, all sides are the same, right? So we have this side times this side, S squared. Because if this is 6, this is also going to be 6 because it's a square. So now over here, we know that this is 6 and this side is 6, right? So to find our surface area for this cube, we're going to have to use the formula for a square to find the surface area of a square, which is A equals S squared. So the surface area of this square right here is 6 times 6, which is 36. So that is just for this side though. This is the area of just this square. That's this one right here. But now we have to go through and find the surface area of the rest of these as well. But in a cube, we have to remember that each face, all right, this is a face, this is a face, this is a face. These are all faces of our cube. They're all going to be the same lengths because it's a square, right? It's a cube. All sides of a square is the same. So this is 36. This is going to be 36. This is going to be 36. This is going to be 36. 36 and 36. Because each one of these lengths are 6 times 6, 6 times 6, 6 times 6. So to find the surface area, we now have to take 36 times how many blocks we have. 1, 2, 3, 4, 5, 6. So we're going to have 36 times 6, which is 36, 18, 19. Our surface area is 216. Are there any questions for this first one that we did? Okay, good. We understand that each side is the same. We're just unfolding it. Although this isn't as big as this is just a model, right? We're told that the length of this is 6. Each side is going to be 6 then. Another way we could do this, if you wanted to, was we know this is 6, and we can compose our squares into a rectangle. So if this is 6, this is 6, this is 6, and this length right here is 6, we know that this long line right here is going to be 24. So we could turn this into a rectangle and do 24 times 6 for this one right in here. Does that make sense? Okay. One thing I want to talk about is faces and edges, because this is going to show up on some of your tests and quizzes. So this is a face. Each part of the box is a face. So this is a face, this is a face, this face, face, face. Another thing is we have to look at edges, okay? So how many edges would a cube have? That's just this line, these lines, okay? So for a cube, we're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 for what we can see, right? And then we also have to remember to count the bottom. So we're gonna have lines back here, right? If I could draw this right. And lines right here. And a line right here, back here. So we have these lines as well, right? Because we're making a cube. So we're gonna have 4 on the bottom, 4 on the top, and then we have this one, this one, this one, and this back one. Okay, does that make sense for how we count our edges? Our edges are just the lines. Make sure you don't repeat counting the same line though. So like when you count this one for the top, make sure you don't count it for the sides as well. But we can review that later on. Right now we're just going to work on making our nets and finding the surface area. So our next one, this was a cube. Our next one is a cylinder. So for a cylinder, the bottom is a circle and the top is a circle. And remember how we used the paper, how we wrapped it around the water bottle and unfolded it and it became a rectangle? So that's what we're doing here, we're unfolding it. So we unfolded the middle and turned it into a rectangle, and then the tops we just kind of opened up. They're like flaps. So we have our circle and our circle. So in order to find the surface area of this, we have to find the area of this rectangle, the area of this circle, and the area of this circle. So we already know, we'll put in our information, what we already know. We already know that this is 6, because that's what this says, right? And we know that this line right here is 4, and these are the same, these are equal, so this one down here is 4. So when we find the area for this circle, it's going to be the same as this circle. So just remember that we are finding surface area, which means it's the outside of an object, okay? We're not finding what's in it. Remember that was volume, we're filling up, that's volume. For this, we're finding the outside of the object. So for our can of soup, we're just looking for the can itself, okay? So our formula for finding the area of a rectangle is length times width. But here's our problem. We only have our length, right? We don't have this one down here. So how are we going to figure that out? Does anyone remember? We talked about how our circles and our rectangle were correlated when we did this. So if we were to unfold our circle, if we were to take apart our circle and lay it out, it would actually come this line right here, the circle, our circumference of the circle is going to equal the length of our rectangle, okay? So in order to find this length right here, this amount right here, this number, we have to find the circumference of a circle. So not only do we have to use our area formula, we also have to use a circumference formula, which is C equals 2 pi r. So we'll have to do that first. So what is the r stand for? Radius. Now radius is 4. So we're going to have C equals 2 times pi times 4. So our circumference is 8 pi, okay? So this length right here is 8 pi. So now we can plug our 6 and our 8 into our area formula for our rectangle. So we're going to have A equals length times width. We fill in the blanks. A equals 6 times 8 pi, which gives us, someone shout out what 6 times 8 is? 48. 48 pi. So our area for our rectangle is 48 pi, okay? So now we have to find the areas for our circle in order to find the total surface area. Because we don't want just the surface area of this, we want the area of all of it, the whole surface area. So what is our formula for our circle? It's going to be A for area equals pi r squared. You already told me what the radius was. R's radius, 4. So we're going to do A equals pi r squared, which is going to be pi times 4 squared. What is 4 squared? Is when you multiply it by itself. So 4 times 4, because we're multiplying 2 of them. So 4 times 4 is 16. Good. 16 pi. And in order to find the area of all 3 of these, we have to add them together, right? We already know that this one's 16 pi. because they're even, the circles are the same. 16 plus 16 is 28. So we're going to have 28 pi plus 48 pi. So our answer is going to be 76 pi. So our total surface area for this one is 76 pi. Okay? So we have one more down here. Does anyone know what this shape is? Can someone tell me what this shape is called? It's a triangle. It's composed of all triangles. It does not have a square base, so it is not a pyramid. This is called a tetrahedron. Okay? And when we unfold it, it looks like this because it is not a pyramid. A pyramid has a square base. So a pyramid unfolded is going to be a square with triangles outside of it. Kind of like this. Kind of looks like a star. That was a really bad drawing. But it would have a square middle. This one has a one middle, or a triangle middle, and three triangles outside of it. So what's going to happen is these are going to, if this is flat, they're going to come up to each other and meet at the center, right? And close in. But this is going to be on the bottom. This is like our base, like our floor in our house. You can unfold your house. You can find the surface area of your house. It's just like unfolding your house, right? You're not trying to find what's inside of it. You're just trying to find how big it is on the outside. Maybe you're stringing lights, or maybe you are maybe just finding the circumference like we did for the circle and you're putting a garden around it. Or maybe it's time to paint your house again and your parents are like, how much paint do we need? You can say, I know just how to figure that out, Mom and Dad. I'm just going to find the surface area of the house and then we'll paint the outside of the house. Have the right amount of paint. So there's some ways that you can incorporate it into your real lives, right? So for a triangle, we're going to find the area of three triangles. And they're all equal, okay, a tetrahedron. They all have equal lengths, equal sizes, right? And so our formula for this is going to be A, area, equals half times our base times our height. So our base is the bottom, which is 3, and our height is 8. So when we come over to this triangle, we have our base here is 3, and our height is 8. Okay? So we're going to do A equals half times BH, and then we're going to plug in our numbers. So we have half times our base, which is 3, times our height, which is 8. Can someone tell me what 3 times 8 is? 24, good. So we're at our half times 24. What is half times 24? It's like dividing, right? So we do our 24 on top of our times our 1, right? We're going to have 24 over 2, good. And now how do we simplify? How many 2's go into 24? 12, good. So our area for this inside triangle is 12. If they're all equal, what's the area of this triangle? 12, 12. And this one, 12, good. And then we'll just erase this. 12. So to find the total area, we're going to add up all of these areas, right? So we have 1, 2, 3, 4 triangles. They're all 12. So what is 12 times 4? 48. So our area for this tetrahedron is 48. Okay? So like I said, ways you can use this in real life is wrapping boxes for like birthdays or Christmas, which we are going to do today. That's one of the stations. And then we also, like we talked about painting, you can use this for painting. I have a worksheet for you guys to do. And then you're also going to get to find surface area of things around the room. So I have the trash can. You're gonna have to find the surface area of the trash can. You have to find the surface area of just things like that. I put them at the table in the back. So go ahead and pick up your worksheets and we'll get started on that.